14 hours ago, NASA's James Webb Space Telescope confirmed something that should not exist. An event carrying a 0.00001% probability of natural occurrence. And once you hear what actually happened, you are going to question everything you thought you understood about what travels between the stars and why. The object is called 3I Atlas. We had been tracking it for months. Every model, every simulation, every projection pointed toward the same straightforward outcome. A standard gravitational slingshot around Jupiter, the kind of routine celestial interaction planetary scientists observe and catalog without losing sleep. Instead, what unfolded over the past 48 hours has triggered emergency data sharing protocols between the world's most advanced space agencies, a classified briefing at ESA headquarters, and a complete shutdown of civilian telemetry from every Jupiter-facing instrument currently in orbit. None of that happens for a passing rock. Here is what the data actually shows. 3I Atlas, traveling at 65,000 kilometers per hour, released a highly concentrated stream of complex molecular isotopes directly into Jupiter's equatorial cloud belts, not scattered randomly into space the way any known comet behaves. Directly into a specific atmospheric band, at a specific vector, with a precision so tight it demands either an internal mechanism we have never encountered before, or something far more deliberate than we are comfortable acknowledging. The scale of what followed is genuinely difficult to frame in human terms. Within 42 minutes of the initial release, 33 billion tons of heavy exotic elements had been injected into a localized atmospheric band on the largest planet in our solar system. The probability of a random cometary outgassing event hitting the precise atmospheric vector required to trigger this specific chemical chain reaction sits at roughly 1 in 4.7 billion. For perspective, that is the equivalent of dropping a single grain of sand from low Earth orbit and striking a predetermined pinpoint on the ground while accounting for hurricane-force winds. And NASA's NIRCam instrument captured every second of it happening in real time. What makes this genuinely alarming is not just the precision of the injection, it is what the injected material did afterward. Conventional thermodynamic models are unambiguous on this point. The specific molecules released by 3I Atlas should have burned up or dispersed chaotically the moment they entered Jupiter's radiation-saturated environment. They did neither. They organized. They bonded. They began forming stable structures inside a planetary atmosphere that, by every law of chemistry we currently hold, should have torn them apart instantly. The European Space Agency, using the Jupiter Icy Moons Explorer's telemetry, independently verified these atmospheric changes. Their diagnostic algorithms returned the same result 3 consecutive times before analysts would accept the output. When an institution of that standing initiates emergency data sharing with JPL over a cometary flyby, the scientific community takes notice. And when you combine that institutional response with what the raw numbers are showing, a self-organizing chemical storm expanding inside Jupiter's cloud layer in real time, you begin to understand why every deep space array currently pointed at the Jovian system is running at maximum capacity right now. The initial chemical injection was not the full story. It was not even close. What scientists now understand, after 48 hours of continuous observation, is that this first phase was precisely that. A first phase. Something calculated. Something sequential. The question driving the classified briefings, the emergency protocols, and the locked telemetry feeds is not what 3I Atlas is made of. The question is what it just built inside Jupiter's clouds. And the answer to that question is where this story becomes something else entirely. To understand the full weight of what is happening inside Jupiter's atmosphere right now, you need to start with what 3I Atlas actually is. Because from the moment it appeared on our instruments, it refused to behave like anything we had cataloged before. Discovered on August 12, 2025, it became only the 3rd confirmed interstellar object to enter our solar system, following Oumuamua in 2017 and Borisov in 2019. But the comparison to its predecessors ends at the classification label. Both earlier visitors were relatively inert, cold, passive objects drifting through on hyperbolic trajectories, shedding material predictably as solar radiation warmed their surfaces. 3I Atlas operates by an entirely different set of rules. It possesses a thermal density that defies our standard astrophysical models. It is highly active internally, yet it produces no traditional cometary coma. Rather than shedding water ice loosely into surrounding space, it appears to retain internal pressure, releasing material only under highly specific gravitational conditions, as though it has a threshold, a trigger point, a condition that must be met before it acts. That behavioral pattern became impossible to ignore when the object crossed Mars's orbit and did absolutely nothing. No outgassing. No thermal signature shift. No material release of any kind. It remained completely dark, waiting, in the most literal observational sense, until it reached exactly 2.4 million kilometers from Jupiter's cloud tops. Then it moved. NASA's James Webb Space Telescope, operating through its near-infrared camera, detected the initial breach at exactly 4:17 UTC on April 21, 2026. The instrument registered a sudden, massive spike in heavy metallic isotopes, specifically ionized titanium and vaporized chromium, ejecting from the object's southern hemisphere at 14 kilometers per second, not from its sunward face, which is where solar heating would drive outgassing in any natural comet, from its southern hemisphere. Directional, targeted, and timed to the precise moment Jupiter's gravitational gradient reached a specific threshold. ESA's Jupiter Icy Moons Explorer, currently en route to the Jovian system, confirmed the identical chemical signature minutes later using its sub-millimeter wave instrument. The W.M. Keck Observatory in Hawaii then cross-referenced the emission spectra through high-resolution spectrometry and returned the same result. 3 independent observatories, 3 entirely different detection methodologies, one conclusion. There is no natural framework in which a cometary body harbors vaporized titanium and then releases it with this degree of directional accuracy. Anomaly 1 was confirmed. Then came Anomaly 2. On April 22nd at 11:33 UTC, the metallic plume did something that overturned every dispersion model JPL had prepared. It did not scatter into Jupiter's gravitational well the way injected material is supposed to. Instead, the exotic elements began self-organizing within 0.03 degrees of Jupiter's equatorial line, bonding with native ammonia ice clouds to form complex molecular chains that had never been predicted, never been modeled, and never been observed anywhere in 4 million years of recorded cometary data. NASA confirmed the stable band formation at 14 o'clock UTC the same day. Over 99% of all known comets exhibit what scientists call isotropic outgassing, material ejected equally in all directions as solar heat drives sublimation. 3I Atlas emitted its entire payload in a focused beam with an angular dispersion of just 2.1 degrees. Picture holding a flashlight in the middle of a hurricane and watching the beam freeze the wind into a perfectly straight line that refuses to waver. That is the degree of cohesion now locked inside Jupiter's upper atmosphere. By the evening of April 22nd, Anomaly 3 had appeared. The newly formed molecular band began generating its own faint, rhythmic electromagnetic pulse. Jupiter's magnetic field is one of the most violent and chaotic radiation environments in the solar system. It should have shredded these delicate metallic structures within minutes of formation. Instead, the injected elements appeared to be acting as a stabilizing agent, generating a localized bubble of magnetic calm inside the most turbulent planetary atmosphere in our cosmic neighborhood. And that was only the third of 7 documented anomalies, each one compounding the impossibility of the last. By the time scientists had documented 3 separate anomalies in under 48 hours, the working assumption at JPL, ESA, and research institutions from Caltech to Cambridge had quietly shifted. No one was saying it publicly yet. But the data had already moved the conversation from unusual natural event to something the models had no category for. Dr. Avi Loeb at Harvard, who built his reputation on methodical, evidence-based analysis of interstellar phenomena, reviewed the spectral data and stated plainly that what he was seeing challenges the fundamental limits of naturally occurring chemistry in deep space. That is not the language scientists use when they are looking at something strange but explainable. That is the language they use when the foundations underneath a field of study start to crack, and when the scientific establishment acknowledges that an event requires rethinking foundational theories of atmospheric synthesis. The appropriate response is to examine the evidence very carefully. Here is the most precise way to frame what the physics is actually showing. The conventional explanation for cometary outgassing is a chaotic, thermally driven process governed by the inverse square law of solar radiation. Material heats up, sublimates, and disperses randomly based on the object's spin, surface composition, and proximity to the sun. There is no natural mechanism by which a comet selectively retains exotic metallic isotopes until reaching a gravitationally specific point, then releases them in a focused directional beam into a planetary atmosphere, where they subsequently organize into a coherent stable structure against 400 km/h equatorial winds. Yet that is the documented sequence of events. Imagine dropping a single drop of ink into a turbulent, boiling ocean and watching it instantly form a perfectly geometric glowing grid that not only refuses to dissolve, but begins to grow. Now scale that image to 33 billion tons of exotic metals holding stable formation inside the largest planetary atmosphere in our solar system. Then, on April 23, 2026, at exactly 9:15 UTC, NASA's Juno spacecraft, repositioned for an emergency flyby, detected something that rewrote the conversation entirely: a massive fluctuation in the localized magnetic field directly beneath the chemical injection zone. And this was not a field distortion caused by the foreign material's magnetic properties interacting chaotically with Jupiter's environment. It was the opposite. The instruments recorded a sudden, measurable drop in atmospheric entropy within the injection zone. From a thermodynamic standpoint, this is not just unusual. It is physically backwards. The second law of thermodynamics is one of the most rigorously tested principles in all of science. When foreign material is introduced into a chaotic high-energy environment at 65,000 km/h, entropy, disorder, should increase dramatically. The system should become more chaotic, not less. But the localized entropy dropped. The vaporized titanium and chromium were functioning as a thermal sink, forcing Jupiter's native ammonia and hydrogen into organized crystalline lattice structures. The thermal differential between the newly formed metallic band and the surrounding atmosphere reached 84 Kelvin. And the boundary of that thermal layer was holding steady within 0.05 degrees of latitude, a precision that no fluid dynamics model of a gas giant atmosphere has ever predicted or replicated. JPL's most advanced fluid dynamics simulators were deployed to model this behavior. The diagnostic algorithms, calculating the interaction between highly charged metallic ions and Jupiter's deep metallic hydrogen mantle, crashed repeatedly into mathematical impossibilities. The chemical material was not mixing with Jupiter's atmosphere. It was actively resisting the planet's magnetic flux. Every simulation returned the same result: cohesion exceeding all natural entropy thresholds. Then, at exactly 10:44 UTC on April 23rd, 3I Atlas did something that eliminated the last remaining possibility of a passive natural explanation. The object's rotation axis shifted. Its spin rate altered by 0.12 degrees per second, and the new orientation locked the object into a direct line of sight with the exact chemical band it had deposited inside Jupiter's atmosphere. The probability of an interstellar comet containing this specific ratio of heavy metals is approximately 0.02%. The probability of releasing that payload at the precise orbital window required to penetrate Jupiter's upper troposphere without burning up is approximately